Okay, so Unit 12, we have... That makes no sense. Circumference and area. Well, if it's circumference, we must still be in the land of circles. So for the first part, we'll work with circumference, and then we'll move on to work with area. And not only will we do the circumference of a circle, what if we only want part of the circle? What if we just want the length of an arc? Of course, the nice thing about circumference is if I'm given the diameter, I can find the circumference. Or if I'm given the radiance, I can find the circumference. Because the diameter is just 2 times the radius. So circumference can be pi times the diameter, or the circumference can be 2 times pi times the radius. So let's try some examples. Okay, if I know the radius, I'm going to do 2 times pi times the radius. In this case, 2 times pi times 9. 2 times 9 is 18. So if I want an exact answer, 18 pi centimeters. If I instead want a decimal, come up with about 56.55 centimeters. Some students will try to use 3.14 as an approximation for pi. Notice the answer is a little bit different when you do that. I recommend using the pi button. Right? Here the directions ask for both exact and rounded to the nearest hundredth, so I did it both ways. Always kind of refer to the directions. If the directions are not specific in how to show the answer, then it's kind of your choice on whether you want to leave it exact or use a calculator. Okay, this time they're talking about the diameter, so instead of 2 times pi times the radius, I wanted to do pi times the diameter. But notice what I'm starting with. I'm not starting with the diameter, I'm starting with the circumference. So 30 equals pi times the diameter. Divide both sides by pi. And there is an exact answer. 30 over pi feet. You can see why sometimes it doesn't make a whole lot of sense, because if you tell someone it's 30 over pi feet, they're going to look at you like, what on earth does that mean? But if you tell them, oh, it's a little more than 9.5 feet, it's about 9.55 feet, that makes a lot more sense. Now, of course, sometimes instead of words, sometimes we just get pictures. Because I'm given the diameter here, I'll do pi times the diameter. The diameter was in feet, so the circumference is in feet. Again, here's a picture. This time I'm given a radius. So I want to use 2 times pi times r. 2 times 3, of course, is 6. Notice I was not given units. So if I don't know if it's feet, inches, centimeters, leagues, angstroms, right? Got no clue what the unit of measurement is. I just use generic units. Now, what if instead of the entire circle, I just want part of it? Well, if we're talking about the measure of the arc, then we want the degrees. But if we actually want the length of that chunk of the circle, then we're in linear units. We're going to set up a proportion to do this. The length of the arc will compare to the length of the entire circle. The same way the measurement of the arc will compare to the measurement of the entire circle. And of course, any circle, the entire measurement is always 360 degrees. And the circumference of any circle, of course, 2 times pi times the radius. This is how I prefer to just remember. Alternatively, could multiply both sides by 2 pi r. But that's not how I usually set things up. You'll see it both ways on textbooks. We're looking for the length of the arc. So here's my proportion that I want to set up every time. Length of the arc, I don't know, I'm trying to find it. Length of the circumference, well, I know the radius is 8, so I can quickly figure out the circumference has to be 16 pi. Measure of the arc, diagram says it's 60 degrees. Measure of the circle, it's always 360 degrees. Notice that the degrees are going to cancel out here. All right, I've got 1 times 60 degrees, that's a numerator. 6 times 60 degrees, that's a denominator. That reduces to just 1/6. Multiply both sides of the equation by 16 pi. Simplify the answer if possible. 16 over 6, of course, reduces to 8 over 3. So I've got 8 pi over 3 centimeters. Or I can grab a calculator, push some buttons. I come up with about 8.38 centimeters. Hey, this is different. This time I want the circumference. Set up the same proportion. Length of the arc, 4.19. Length of the circumference, trying to figure that out. Measure of the arc, 40 degrees. Measure of the circle, 360 degrees. Again, notice the degrees cancel. Leaves me with just 1/9. Solving a proportion. Cross multiply. And so I've got 37.71 inches. This time I actually want the measure of the arc. So I already know the length is 44. The circumference, well, I'm given the radius. And if I know the radius, I can calculate the circumference. Measure of the arc, we don't know that. Measure of the circle, it's always 360 degrees. Multiply both sides by 360 degrees. Calculator punch buttons. 164.98 degrees. That's the measure of arc, RS. Now, how am I supposed to read that font? We gotta clean that font up. That's not acceptable. Much better. I can read that. IXL U3, arc measure and arc length.